Today we will use scriptable objects as a handle for game objects in our scene. This is useful for prefabs that require a target game object which is not part of the prefab itself. To do this, we will employ the following pattern. As usual, the black classes are provided by Unity and the blue classes are our creations. The GameObject handle exposes a property GameObject. It is important that we use a property for this, otherwise the field will get serialized, which is useful in scriptable objects for certain data but not for GameObjects. The GameObject set controller will update the GameObject handle with a reference to its own GameObject, for instance the player. Then another component, for instance the translation controller, simply uses this GameObject handle to retrieve the actual GameObject. We will start by creating the GameObject handle. We will write the only test we need for this, and this is the test for the GameObject property. A property is technically a function, so we need to write a test for this. In this test, we simply set the GameObject and then assert that the GameObject is the same as the one we have set. We add this missing property for the compiler, but we must deliberately set weird return values for this property in order for the test to actually fail. The implementation is quite simple. In principle, you could forego testing in this case, because this property is so simple, it basically is just a fancy field. But we use a property for two reasons. First, we do not want to serialize the field. And second, we want to be able to set the GameObject via Unity events. We don't do this right now, but we will do that in the future. But now our GameObject handle is already done. Let's add the GameObject set controller. And here we also need only one test, in which we want to make sure that our component updates the GameObject. So we create a GameObject handle, then we add a GameObject handle set controller, we assign the handle to our controller, and assert that in the next frame the handle GameObject has been updated. Before we run the test, as always, we have to add the missing field. We implement this via the start method. And this component is done as well. Currently, our translation controller requires a target GameObject. We want to assign a GameObject handle, but I also want to be able to assign a GameObject in case I need a reference from within my prefab. To solve this, we will create a wrapper which can accept a GameObject or a GameObject handle and exposes the corresponding GameObject. Let's put it in a folder called wrappers. And because this wrapper will be used as a field for our components, we will use a struct for this, which is the canonical way to do it in Unity. Our first test will make sure that we expose the assigned GameObject. We create a new wrapper, assign a new GameObject, and then assert that the exposed GameObject is the same as the assigned GameObject. We will add the missing properties and fields and run the test. And the implementation simply returns the assigned game object. In the second test, instead of assigning a game object directly, we will assign a game object handle and assert that the game object we expose is the same as the game object the handle exposes. And of course, this test fails. We can solve this with the double question mark operator, which will simply return the handle game object when the game object is null. I have updated the game object property to throw an exception when the handle and the game object are assigned at the same time. The source code for test and implementation can be found in the repository. A new issue arises when we use this wrapper in our translation controller or camera controller. We cannot access the transform property directly, but have to use GameObject. But here it could easily happen that instead of using the property GameObject, we could use the field GameObject, which would cause a null reference exception when we want to use a GameObject handle. To solve this, we first make our handle and GameObject private fields, which breaks our tests because we lost the public access. So instead of setting them directly, we will create a constructor that helps us set those fields. In principle, you could also set those fields via reflections, but in my point of view, when you use reflections in a test, then you do something wrong. After that, we update the tests to use the new constructor. We then add the necessary serialized tags to the struct and the fields so that they show up in the inspector. Now we can finally update the translation controller with our wrapper. We also need to fix our tests. The easiest way to do this is use a search and replace. The game object needs to be supplied via a game object wrapper. And to access the transform, we need to first access the game object. And we need to repeat the same process with our camera controller. Now we can use our newly created features. We create some subfolders for our different kind of scriptable objects. Then we create a menu item for our GameObject handle and add a new GameObject handle for our player. We use a GameObject handle set controller on our player to update the player handle. And then we reference that handle in our camera controller and in our movement directions. And in play mode, everything should still work now. Now we can create prefabs of our camera controller and our movement directions, secure in the knowledge that when a player is in the scene, they will always have the player readily available. And now there is no need to search for tags or names or types in the scene to find the player because the player is plugged in. We also want to add some visual help in the inspector so that we cannot accidentally assign GameObject and GameHandle at the same time. To do this, we will create a property drawer for our wrapper. We won't add any tests in this case for two reasons. First, the behavioral impact of this property drawer is just of an indirect nature. And second, to my knowledge, we don't have a practical interface to actually test the UI drawer functions. First, we need to add the property drawer tag. Then we use the onGUI overload to draw our property. First, we attempt to draw the property as it would be normally drawn in the inspector. The target property is here, but we cannot expand it. Using the overload with include children and setting it to true will solve this. However, when we expand, the height is not updated. We fix this by overriding the getPropertyHeight method. Alright, we made some progress. Now we try to figure out how to actually disable a property. A property can be enabled or disabled with GUI enable. To prevent possible interference with other property drawers, we set enable to true when we leave the method. And now we have disabled the whole target, which prevents us from doing anything with the target. Via find property relative, we can find the actual child properties. So let's attempt to draw the properties separately. And now we seem to draw them on top of each other. Updating the position value will help us solve this. And we are getting closer to getting this sorted out. Next, we remove the label. Now we'll attempt to infer the height difference from the provided position. But this looks messed up. I try to fix this by prefixing a label which also updates the position. But it only added an indentation. Let's lower the property height by a third, essentially removing one line. Alright, now using just half of the height for the new line should work. Let's add a method to decide which of the properties should be enabled. The first property should be enabled if only the first property is set. The second property should be enabled if only the second property is set. If no property is set, all of them should be enabled. We will use the returned booleans to enable or disable the GUI accordingly. And now only one of the properties can be set. This property drawer now is not essential, but it's quite helpful in using our wrapper. A refactored version of this is available in the repository. That's it for this tutorial. Next time we will add some rotation controls for the camera and the player. Let me know what you think, and thanks for watching.